Hello, today we are going to learn how to use chops in Houdini and create something like this. So let's jump into Houdini. And here we have an empty setup. So I will first of all create a SOP network. And you can refer to the lesson on SOPs on how to do this. So press tab and type geo. And let's call this my SOP. And let's go inside and create a sphere. So tab and sphere. And let's change the size of this sphere to 0.25. And then look at this in the scene view. Okay, I also changed the viewport to orthographic. Front viewport. Okay. And then let's zoom out this. So here we have a sphere in the middle of the viewport. And let's hide these things. Okay, so this is our starting point. And let's go up to the object context and create a chop network. So press tab and type chop. And chop stands for channel operator. And now let's call this my chop. You can also use the ch context here and do it inside here, or you can use your obj context and create a chop network and go inside that, and you have the same thing. So let's use the object context for everything as we used to before. Okay, so what do we do here? Now we want to move this sphere around using channels. So let's switch the view to the motion effects view. And if you don't have this, then you can use this plus and new paint tab type and select motion effects view. So motion effects is another name for chops. Okay, so let's try something simple. So press tab and as usual VOP, and here select a channel VOP. And then let's set this to display. Now we can see channel 0 on this curve display. And we want to have two channels, so press P and say we want a translate X and a translate Y, for example. So now we have a TX and a TY channel. Okay, so now let's jump into this VOP chop. And again, we have these things that we don't really need because we will do this from scratch. So delete this and press tab and type snippet. And here we can write VEX code directly. And you can refer to my VEX code lesson to learn VEX. Okay, let's press P here. And now we have this code snippet where we can write our expression. So first of all, because this is a time function, let's see on the timeline that we have now frame 1 to 48. Okay. And let's create, for example, a sine function. So let's type v for value equal, and then sinus and a t for time. And let's see what we get. So here we have a sine function, but you can see we don't have the full cycle. So let's multiply this by pi. And you actually don't have to remember all the decimals. You can use the pi variable or constant here. So now we get one full cycle during the full animation. And you can see the tx and ty is using the same, but we actually want to have the sinus for the y and cosine for the t. So let's see how we can do that. So let's first of all create a float, and let's call this x equal cosine t times pi. And because we are going to use t times pi several times, let's call this a for angle. So let's say float a equal t times pi and end with a semicolon. And then we can use cosine a here instead and end with a semicolon. And for y, we also want to use a float y equal sine angle semicolon. And now we can assign the value to, for example, x. But still we have the tx and ty is the same. So the way we can do this is with an if statement. So if the channel, so channel is the number of this channel from like 0, 1, 2, 3, etc. So if channel equal 0, then we can do v equal x. And if channel equal 1, okay, so this is a little bit easier to read, then the value equal y. So now we have two curves, so the translation x and translation y. And normally you want to clean up a little bit by adding like new lines. So you can see here we have our definitions and here we have our if statements. Okay, so now we want to use these to move the sphere. So let's go back up to our object level and look at the scene view. And we want to move this sphere. So if you see this sphere as an object, then you can edit the parameters here on my SOP. And for translate, you can type chop and then the name of the chop network we just created. So type slash or type dot for the same level in the hierarchy, and then my chop. Actually, let's go up one level and see if this will work better. Okay, so we go up from the geometry node and then we are in the object context, and then we select my chop and VOP chop 1, and here we have tx. And now if we play this on the timeline, you can see that it moves in the x direction. Okay, so let's also move it in the y direction. So go here and copy this expression into the y channel and change this to ty. And now let's look at the result. So now we have the sphere circling around, and it starts down here, and we want to start up here. So let's just offset this. So go into the chop network and add an offset to the angles. Let's say plus 0.5 times pi. So that should move it up here. Okay. And let's also make the sphere a little bit smaller. So go into this SOP and change the scale of the sphere to maybe 0.1 or even smaller, 0.05. Okay. And next, let's go back to our chop and down and edit the vex in this snippet. And now if you look at this, we want something a little bit more interesting than a sphere. So instead we can, let's just pause it. Take the X and offset the distance. So let's add float. Let's call this R for radius and equal. And here we can use arc tangent 2 for 2 parameters, and use X and Y here. And if we then multiply by the radius, then we can have a different distance. And this looks a little bit strange. So let's mirror this around the y-axis. So we can take the absolute of x here. And let's see what we get now. Okay, so this starts to look interesting. So let's zoom out to view. And we can also offset this up a little bit. So let's go to the y and plus 0.25 perhaps. And let's see what we get. Okay, I think we can increase this even more. So let's add 1. And I think this is good enough. So let's just move the view up a bit here. Okay, so now we have an interesting pattern. And let's see what we can do with this in the SOP. So here we can add, for example, a trail, to add a trail to this. So press tab and type trail. And connect this to the sphere. And set the trail length to 10. And now you can see you don't get any difference. And this is because we are animating the complete object as one thing, so the trail will not work. So let's move the transforms we have here. So copy this and go inside the geometry and add a transform. So press tab and transform. And put this after the sphere. And let's paste in these expressions. And now because we are one level deeper, we have to go up one level higher. So this will now have a value here. Okay. And let's copy this into y and change tx to ty. And then remove these expressions from the object level. So go here and delete channels and set these to 0. Okay, now we can see we have a trail. And if we run this, there's quite a bit of distance between each one. So let's change the trail by press P, and the trail length So let's make this a full 48 because we have 48 frames. And let's play this. Or we could double this to 96 and reduce the increment to 0.5. And let's play this. Okay. And now we can add some colors to this. So after the trail, let's press tab and type color. And here we can choose a color, for example, a red color. So that's very easy. And let's place this on the primitive level, because if you look at the geometry spreadsheet, we have now 96 primitives. So if you go to frame 1 and look at the scene view, okay. So we have one primitive for each sphere here in the trail. And let's also change the opacity. So let's add one more node by pressing tab and type Attribute Wrangle. And connect this and display this. And P to edit, and in this case run over the primitives. So it will go through each sphere. And here we can say at alpha equal, let's say 0.5 and see what happens. So now you can see they are semi-transparent. And we want to have the latest one being fully opaque and the tail be transparent. So here we can use two variables. So the first is the at num prim, and that is the number of primitives. And if we subtract then the prim num, and that is the primitive number. So num prim is 96 because we have a tail with 96 items, and prim num is going from 0 to 95. So this will give a value that, let's look at the value instead in the geometry spreadsheet. So if you go to the primitives, then you can see now the alpha is going between 1 and 96. So we need to divide by 96. And we know that that is the number of primitives. So divide by at num prim. And now you can see it's either 1 or 0, and that is not what we expected. And the problem here is that this is an integer, so it will round this to integers. So we need to cast this to become a float. So let's try typing float and see what happens. And you can see this does not work. And if you know C, then you know that you can type parentheses around the type to cast. And this works fine. But if you read the Houdini documentation, it says you should write it like this. And let's see if that works. Okay, this also works. So you can use either the C style casting or the Houdini style casting. And the result is now this. So let's look at the initial version. So this is more or less the same as what we looked at earlier. And here I have I have also rendered this out as I explained in my ROP lesson, and applied a glow inside of Nuke that I also explained in the ROP lesson. I hope this was helpful, and see you next time. Over and out.